Hello everyone. In today's lecture, we will discuss siting and layout of a chemical plant, one of the most important aspects of process safety engineering. Before any chemical plant is constructed, engineers must decide where the plant should be located and how different units should be arranged inside the plant. These decisions directly affect the safety of workers, the surrounding community, and the environment. Poor siting and layout can lead to serious accidents, environmental pollution, and huge economic losses. Many industrial disasters around the world occurred because of improper site selection and inadequate plant layout. By the end of this lecture, you will understand the principles of selecting a suitable site, regulatory requirements, buffer zones, plant layout principles, and lessons learned from major industrial accidents. So in this lecture, we will cover six important topics. First, we will understand why siting decisions are important, especially in rapidly industrializing countries like India. Second, we will study the regulatory criteria that govern the selection of industrial sites. Third, we will discuss the minimum distance and buffer zone requirements between industries and sensitive areas. Fourth, we will learn about environmental impact assessment and the role of site appraisal committee. Then we will study the principles of plant layout, including equipment spacing and building arrangement. Finally, we will examine some major industrial accidents and understand how improper siting and layout contributed to these disasters. India is experiencing rapid industrial growth which has increased environmental challenges. Large quantities of pesticides are used every year and a significant amount of untreated sewage is discharged into rivers and coastal waters. Industries such as tanneries, paper mills, fertilizer plants, and chemical industries release toxic effluents that pollute water and air. These environmental issues highlight the importance of selecting a suitable location for chemical plants. Engineers must consider nearby residential areas, water bodies, and environmentally sensitive regions before choosing a site. Proper siting helps protect public health, reduce pollution, and supports sustainable industrial development. Next, let us talk about the siting criteria. A key principle in plant design is prevention is better than cure. Once a plant is built in an unsuitable location, correcting the problem is difficult and expensive. Before establishing a new industry, environmental clearance must be obtained. Site selection should balance economic growth with environmental protection. Engineers should also plan for future expansion, waste management, and emergency access. Careful planning at the beginning ensures safer operation throughout the plant's lifetime. Key factors governing site selection. Several regulatory and environmental factors must be considered before selecting the site for a chemical plant. First, forest land should not be converted into industrial land because forest plays an important role in maintaining biodiversity and ecological balance. Similarly, fertile agricultural land should be preserved for food production rather than industrial development. The selected site should have sufficient land for installing wastewater treatment plants and solid waste storage facilities. Proper treatment and disposal of industrial waste help prevent pollution of soil, groundwater, and nearby water bodies. The plant should also blend with surrounding landscape and avoid disturbing environmental sensitive areas. Whenever possible, natural barriers such as hills or forests should separate industrial facilities from nearby residential areas. These barriers help reduce the spread of pollutants and provide an additional level of safety during emergencies. Finally, industries are required to establish three ambient air quality monitoring stations around the plant. These stations continuously monitor air pollutants and ensure compliance with environmental standards. By considering all these factors during the planning stage, engineers can design chemical plants that are safe, environmentally responsible, and sustainable while ensuring long-term operational efficiency. Buffer zones are safety distances maintained between industrial facilities and environmentally sensitive areas. Industries should generally be located at least 25 kilometers away from ecological or sensitive regions depending on geographical conditions. Plants should be at least zero point 0.5 kilometers away from coastal areas, rivers, floodplains, highways, and railway lines. For large settlements with populations exceeding 3 lakh people, industry should access the potential impact with a radius of 50 kilometers. These separation distances reduce the possibility of environmental damage and minimize the impact of industrial accidents on nearby communities. Environmental Impact Assessment, which is commonly known as EIA, is a systematic process used to identify and evaluate the environmental consequences of a proposed project. EIA studies various factors such as meteorology and air quality, water quality and hydrology, site characteristics and surroundings, occupational safety, and health effluent treatment methods, transportation and handling of raw materials, pollution control equipment. The major objective of EIA is to ensure that environmental concerns are considered before approving any industrial project. Site Appraisal Committee. The Site Appraisal Committee is constituted by the state government to evaluate and approve industrial sites. The committee consists of experts from different fields including Chief Inspector of Factories, representative from central and state pollution control boards, occupational health experts, town planning representatives, scientists specializing in hazardous processes, local authority representatives. The committee examines the proposed site from safety, environmental, and developmental perspectives before granting approval. After a site is approved, the next step is to develop the site layout and plant layout together. The layout should consider local climate conditions, geographic features, environmental protection requirements, transportation facilities, firefighting arrangements, security systems, welfare facilities for employees, adequate access roads must be provided to every unit of the plant so that emergency services can quickly reach any location during an accident. Arranging units for economic safe flow. Plant layout involves arranging process unit in a logical and efficient manner. The primary objectives are smooth flow of materials, minimum movement of workers, reduced transportation cost, Improved safety hazardous processes should be isolated from other units. Major equipment should generally be separated by a minimum distance of 30 meters. Storage tanks containing hazardous materials should be located at least 70 meters away from the plant to reduce accident risks. Next, let us talk about positioning support buildings and facilities. Support facilities also play an important role in plant layout. Ancillary buildings should be located so that employees can easily access them. Administrative offices and laboratories should be situated away from hazardous processing areas. Control rooms should be close to the equipment they monitor for efficient operation. Utility buildings should be positioned to reduce piping lengths and energy losses. Storage areas should be located near the process units and loading facilities to improve operational efficiency. Goals of a good plant layout. A good plant layout aims to achieve both safety and productivity. The major objectives of good plant layout include meeting production capacity requirements, producing quality products economically, effective utilization of manpower and space, improving worker safety and comfort, controlling project costs, meeting production schedules and deadlines. A well-designed layout increases productivity while reducing operating costs and accident risks. In a fixed position layout, the product remains stationary while workers, equipment and materials move around it. This type of layout is suitable for very large equipment such as reactors, distillation columns, storage vessels, storage areas should be carefully designed. They should be located between loading and unloading facilities and near the units they serve. Hazardous material storage tanks must be maintained at a safe distance of at least 70 meters from the plant. Let us talk about real world accidents and site lessons. Several major industrial disasters highlight the importance of proper siting and layout. First, the Bhopal disaster of 1984 occurred because a highly hazardous chemical plant was located close to densely populated areas. The Flixborough accident in the UK demonstrated the consequences of poor equipment spacing. The Tianjin explosion in China showed the dangers of storing hazardous materials near the residential areas. The Texas City refinery explosion highlighted deficiencies in industrial safety measures. The Seveso disaster in Italy emphasized the importance of maintaining adequate buffer zones and emergency planning. So each of these accidents teaches us that improper siting and layout can have devastating consequences. Let us summarize the today's lecture. Siting decisions are long-term investments that determine the safety and sustainability of a chemical plant. Environmental clearance, EIA studies and buffer zone requirements are essential before constructing a plant. Good plant layout improves operational efficiency and protects workers and surrounding communities. Major industrial accidents around the world have demonstrated the importance of proper site selection and plant layout. Therefore, engineers must always integrate safety, environmental protection, and economic considerations when designing chemical plants. Thank you for your attention. I hope this lecture has provided a clear understanding of the principles of chemical plant siting and layout. Remember that good engineering design begins with selecting the right location and arranging facilities safely and efficiently. Thank you.